Okay. Now are we good, Eli?
Yep, that's
Okay.
perfect.
Thank you. All right. So this was 10, 11. We'll go through this in a little bit quicker, hopefully. Okay, 11 gives us f prime. So again, I like to put f prime in the middle so that I can think, okay, f will be going backwards and f double prime will be taking the derivative. I would always do the derivative one first. I think it's easier to take a derivative than it is to go backwards. But all I'm thinking is I need the slope of f prime. F prime. Is the slope of f prime positive or negative to the left of 0? Negative. So I'd expect f double prime to be below the x-axis. Is the slope, and the slope is steeper as we approach 0. So what's weird is the slope gets steeper as we approach 0. So if I were to pick one point, like let's say right here, maybe the slope is, I don't know, negative a half or something. It's not super steep. But if I picked the slope right there, that's maybe a slope of like 4. It's definitely getting bigger. It's getting more and more steep as I go this way. It's getting more and more steep until at this point, the derivative is undefined. So right here, f double prime is undefined because of a sharp turn. Also, it's like a vertical tangent. And a vertical tangent is undefined because it's almost straight up and down. So as I approach, let's see, we said it's negative. So something like that. Because it's getting to be a really large negative number. If I was right before 0, that tangent line is a really large negative number. So it goes to negative infinity. Okay. On the other side, the slope is positive. So on this half, the slope is positive. Starts out as a really large positive number. As I go this way, it gets less. So what do you guys think?
It's going to look like 1/x.
I feel like I want to confirm it though. Did somebody already check? Is this right? Is this what they have? This is number, what are we in? 3-3? Yeah. So this is f double prime. Okay, so let's go backwards. Let's do f. So think f prime is the slope of f. When we graph this, we want the slope of f to be that graph. I would make an f prime sign chart. Where is f prime equal to 0 or undefined? 0. But what stands out to me is f prime is positive on both sides. So is 0 a max or a min? Neither. In this case, it would be neither, right? Because f prime didn't change signs. So the graph of f won't have a max or a min. Let's say I could talk about concavity. Second derivative is undefined at 0. Is the second derivative positive or negative for values to the left of 0? Negative because it's below the x-axis, and the second derivative is positive, which means the original function went from concave down to concave up. Okay, so we're going to start with a function that's concave down to concave up, and there's not a max or a min. So that's one example, because it did go, as I look at this, it did go concave down, change to concave up, and it's always increasing. So that's one possibility. But again, it could be shifted up or down. Okay, and then what was the other question, 12? Okay, find the vertical asymptotes. Okay, so this one's a review one. Okay, how do we find vertical asymptotes? What do we do? Bottom equal to 0. This denominator looks like it's going to factor pretty nice. It's an x minus 4 and an x plus 2. They'd multiply to a negative 8 and add to a negative 4. So the function, I'll just rewrite it, is this. Once you have it in factored form, Your vertical asymptotes are the zeros of the denominator. Wait, I messed up. That was a plus. This is a -2. So we have our vertical asymptotes. End behavior, what are they asking for when they ask for end behavior? What do we have to consider? Yeah, Michaela. Exactly. So think what happens as we go to positive or negative infinity if it's different. If I was to take the limit of that function as we go to infinity, we just reviewed this. What's our rule if you go to infinity? The powers. Good. So Parker, what would you say this one is? 0. Very good. If it's bottom heavy because the denominator has a larger power, it's 0. So you could conclude that it has a horizontal asymptote at y equals 0. That's often what we call end behavior. It's telling us what's happening at the end of the graph. Relative extrema, what should we do to find relative extrema? A number line, a sign chart, an F prime sign chart. Okay, I'm going to think through if I can avoid it. I'm going to go -2. I know that there's a vertical asymptote. +4. I know that there's a vertical asymptote. Here's a horizontal. I know it's going to approach this way, approach this way. I guess I do want to know if there's a couple things could happen. Let me show you. So this could go like this could go like this, and then like that. So that's one possibility. If it looked like this, there would be no max or min, right? The only way there would be a max or min is if the middle piece turned and went something like that. And if that happened, then these ends would have to be up here. I'm trying to think this through because I really don't feel like taking the derivative of that and making a sign chart. Did you get the one I just did?
Yeah.
Which means we do have to. So let me, I guess my shortcut is really going to work. So let's find F prime. F prime, let's see, it's the bottom. I guess I'll write the bottom in x squared minus 2x minus 8, so just the original bottom. The bottom, times the derivative of the top. I didn't need to worry about that. Minus the top. No, guys, bottom times the derivative of the top, yeah. Minus the top times the derivative of the bottom. I'm off today, so you guys better be watching me. All over the bottom. Quantity squared. Looks bad, but if I distribute that negative, I've got that on top. This on the bottom, I would never FOIL out. I need to ask myself, when is this equal to 0 and when is it undefined? When is a fraction equal to 0? Top equals 0. That's easy enough. That's at x equals 1. When is the denominator undefined? We already know. That denominator is the same denominator that we have right here. It's just squared. So it has the same x values make it equal 0. So it's undefined at 4 and -2. But I already know 4 and -2 can't be max and mins. How do I know that they can't be max and mins?
Because they're substance.
Yeah, because they're vertical asymptotes. So the only candidate for a max or min would be at 1. So I could do an F prime sign chart. I'm still going to list -2, 1, and 4. But really the only interval I have to check is right here. Because I know -2 and 4. Well, I guess I might as well. It will help me graph. So I want to know if F prime is positive or negative. Here's F prime. What's true about the bottom though? Always. Always positive. That's going to save ourselves some time. All we have to do then is check the top. If we plug, let's say -3 into the top, is that positive or negative? Positive. If we plug in 0, is the top positive or negative? Positive. Double check me though. You guys agree? Okay. What if we plug in a number between 1 and 4, like let's say 2? Negative. We plug in 5. Negative. So this is a max. The function went increasing, increasing, decreasing, decreasing. So I'll come back to the graph that I was expecting. So it's increasing at first. This is the end behavior, so I know it's going to go up. I had the asymptote, I just didn't know if we'd go to positive infinity or negative infinity. If it's increasing, it had to be there. In the middle, it had to go from increasing and then change to decreasing. decreasing at 1. I probably better find the actual max. At 1, I need to know where that y value is. How would I find the y value? Okay. So if I plug it into the original, 1 minus 2, -1 minus 9, -9. Somebody agree? Okay. -1 over 9. Thank you. Figured it would be closer to the x-axis. Okay, -1 over 9, so just barely below here. So it was increasing, then it began to decrease. And then after 4, the function was decreasing. All of this should fit the stuff that we've already talked about. I expected at this asymptote for one side to go to positive infinity and the other side to go to negative infinity because it was an odd asymptote. Same thing here. So it kind of is confirmed with everything else. And that's everything. Okay, let's look at, I think we just had one last little thing today. Did we cover everything? Oh yeah, so good. So today actually you guys get to work on your assignment and we'll just do a few of them together. So, oh wait, no, just kidding. We're done with 3-3. I'm gonna save the rest of the 3-3 assignment because the rest of 3-3, the other problems are all review problems. So we're just gonna save those for next week when we review. So we're actually gonna cover 3-4. So we're gonna skip ahead to 3-4. Ah. Dang it. I got your hopes up, and now it's actually a harder section. It's story problems. Okay, but they're not bad. There's like no new calculus. All an optimization problem is a max or min question. And we've been finding max and mins, and finding max and mins aren't difficult. The only thing that makes it more difficult is they don't just give you some equation and say find the max of this equation. They want you to have context to it and write an equation of a story problem. These are not as difficult as they seem at first. After we do a couple, they're really, the calculus part isn't hard. So it says, okay, one of the most common application questions in calculus involves finding max and min. So you first will choose variables and draw pictures. So we've done related rates. Do you guys remember related rates? Related rates and optimization problems. These are like our only 2 story problem type things for right now. Just like with related rates, we're going to have to draw a picture, choose our variables, write a primary equation. Often the equation is still geometry, so we use a lot of geometry. You're maximizing the volume or you're maximizing the area. Okay, you're going to rewrite so that you only have one variable in each one. This may be your secondary equation. Find your domain, and then step 5 is like our standard calculus stuff. So when I think of these, I always think, okay, I need an equation of something that I'm trying to maximize or minimize. Then you always have a constraint. So you have something that will prevent you from making it as big as possible. So let's say I wanted you to maximize a yard, but your constraint is you only have so much fencing. So you always have like one thing that's limiting it from being as big as you would like, and then one thing that you're trying to maximize. Or I could say, I want you to make a box. I want the volume of the box to be as big as possible, but I want you to use the least amount of material. So you have something that you're trying to maximize and then some constraints, something that you have to follow. So they usually come down to you have to have 2 equations, and then you're going to combine your 2 equations and take the derivative. Okay, so this question, the first example, it says a box with no lid is made from 48 centimeters squared material. Units are always helpful. So when it says centimeters squared, what is it referring to? Area, because those are units for area. So those units, once I see those, I think, okay, we're referring to area. That's our constraint. If the box must have a square base, find the dimensions that will produce the maximum volume. Okay, and then it's telling us what they want us to maximize. They want us to maximize the volume. Explain the meaning of your answer in the context of the problem. Okay, so they've drawn a box for us. They said it has to have a square base. I'm just going to choose then to call each of those sides of the base x. If both of those are x, they didn't tell us height. What do you guys want to call the height variable? H makes sense. Okay, so this is open. It said it's a box with no lid. So they're trying to shade it where you have like the 4 sides and the bottom, right? So that's what we're working with. Yeah. They wanted us to maximize volume, so we definitely need a volume equation. What is the volume of this box? What's the volume of any box? What's our rule? Like length times width times height, right? Good. And so length times width, that's x times the height. So it's reasonable to say the volume of this box is x squared times h. whatever you're trying to maximize, you're going to take the derivative. I do not want to take the derivative though if there are two variables. So before you take the derivative, you have to work with your constraint, and so that this gets down to one variable. So now let's think, okay, how can we work with this 48 centimeters? This is like the centimeters squared. This is the material that we can use. So you can only use 48 centimeters squared to build this box. What pieces do you have to build this box? How many sides? 5 total, right? There are 4 going around the outside and 1 on the bottom. Let's do the bottom. What's the area of the bottom? Because again, we're talking area here. What is the area of the bottom? X squared. So I know the area of the bottom is x squared. Then we have 4 sides. Okay, so this was the bottom. And then we have, this is the sides. So think of one of these sides right here. Because it's a square base, all 4 sides are the same. What's the area of that side?
Or HX.
Good. So you can call it XH, HX, doesn't matter, but one of them is that. We have 4 of them. We have 4 XH. That's our constraint. Okay? By constraint, meaning this is what's limiting us from making the box as big as we want. Once you have this equation, you just have to solve it for either X or H, and then take this equation and plug it in here before you take the derivative. Choose whichever one's easier. Do you think it will be easier to get X by itself or H by itself? H, because there's only one of them. So let's try to get H by itself. Okay, what would you need to do to solve that equation for H? Right, so we'd have 4xh equals 48 minus x squared. So we move that over. We could divide by 4x. So again, you choose whichever one is easier. So H is equal to 48 minus x squared divided by 4x. Then I take this and I'm going to replace H with it. So when I write this volume equation, I'm going to do it up here. My volume equation is x squared times H. In place of H, I write that, and what will be good is then the entire volume equation will only have 1 variable instead of 2. So my volume equation will be x squared times, I know it looks ugly, but it's going to work out okay. In place of H, I have that. I would simplify before we take the derivative. How can we simplify this a little bit? Yeah, so like the x squared and the x, those can go. I could take this x that's left and distribute it through. Right, not bad. That way I can avoid. So on top I'd have a 48x minus x, cubed, all over 4. Guys, double check me. Okay. Do I have to do quotient rule?
No, you can divide that 4 twice.
Yeah, well, I could divide the 4, or to me, if it's just a constant, I always just think of it as 1/4 times it, because then I can just multiply at the end. I don't want to work with a fraction if I can avoid it. If you have a constant in front, you just keep it there. Yeah. I reduced the x first. I'm glad you asked. So I took, it was x squared right here, but I canceled out the x from the bottom with one of those. So I was only distributing an x through. Thank you though, because if I mess up, I want to catch it before I go too far. So yeah, please speak up if you think there's something. Okay, once you have your volume equation simplified, then you can take the derivative. So the derivative is always like the easy part. So I'm going to write v prime, I guess I'll just write. I want the derivative of velocity, not velocity, volume. Okay, the constant in front doesn't go anywhere, and I just take the derivative of each piece. The derivative of 48x is 48. The derivative of x cubed is 3x squared. This is v prime. What are we even trying to find in this question? A maximum volume. So I'm trying to find a max of this. If I'm trying to find a max, kind of side note, remember a max occurs when what happens? Let's see, positive to negative, right? And she said f prime. In this case, I'll just say v prime. So when v prime changes positive to negative. So I know that this is what I'm looking for. So if you're looking for a max, you need the derivative to change positive to negative, which is why we found the derivative. So we're just going to do a first derivative sign chart like what we've been doing. So to find a first derivative sign chart, you would set the derivative equal to 0 because that's where it could possibly change signs, or undefined, but on this question, it's never undefined. So this will equal 0 when 48 minus 3x squared equals 0, or when 48 equals 3x squared. We divide by 3. 48 divided by 3 is 16. Take the square root, and what does x equal? Plus or minus 4. In this case, do you think we need to consider both? Which one can we ignore? Negative, because x is referring to a side length, so we really only need to worry about x equals 4. Now, I shouldn't box that yet. Yeah.
I did something a little.
Okay.
Oh, there we go. Okay.
See it?
I still have a negative though.
But you should ignore the negative because I had a negative.
Well, no, I had a negative, so I couldn't take the square root.
Oh.
Added that on.
Yeah.
Okay.
How do I prove it's a max and not a min? What do I have left to do? What have we done on other questions to decide between a max and a min? What? A sign chart. So I want to do a sign chart. You could do second derivative, but I generally want to avoid that if possible. So I'm just going to do a v prime sign chart. I would do 0 because I can't have negative values. So I just put 4 on here, and I'm going to see if the derivative of v prime is positive or negative. I'm going to take a graphing approach because this straight is an upside down parabola. We would have crossed at a negative 4 and then a positive 4. So v prime changed positive to negative. Is 4 a max? Yes, because v prime changed positive to negative. Read these questions again to make sure, because sometimes they ask for the dimensions and sometimes they ask for the actual volume. This question said, find the dimensions of the box that produces this maximum volume. So what we know is we need x to equal 4. So the dimensions of this box would be 4 by 4 by the height. How am I going to figure out the height if x is 4? Into which one?
The one that tells you height.
The one that tells us height. So look over here. Here's our height equation. Height is 48 minus x squared divided by 4x. So we know x is 4, so we plug 4 in. So 48 minus 16 divided by 16. 48 minus 16 is 32 divided by 16. These are, I think, super common, like ACT-like questions. It's just on an ACT, you could graph the function and just find the max on your calculator. They wouldn't expect you to do it with calculus, but the setup and the story problem way of asking it, I think is pretty common there. Okay. Let's look at the next one. Okay. So the next example, they're just talking about some numbers. It says the sum of two non-negative numbers. Okay, what's the difference between saying non-negative and positive? So little side note. Non-negative, good. Versus positive. Non-negative could be negative or 0. Positive would have to be like values greater than 0, not including 0. If that makes sense. It always kind of bothers me when they say non-negative. Like, why does they just say positive? It's because you can include 0. Okay. So non-negative numbers, the sum, they add to 30. This question here is what strikes me as like a standard ACT question. What equation would you write if it says the sum of two numbers is 30? Sure. So you could say two numbers add to 30. So that's our constraint. This is like what we have to make happen. The two numbers have to add to 30. Find both numbers if the sum of twice the first plus the square of the second is a max. So they want us to find the sum. I'm going to write, we want the sum. We want the sum of twice the first, so 2x, plus the square of the second, so plus y squared. Always name this. The place where I see students make mistakes is they'll write this equation, but they like don't give it a name. Always give it a name because that's the thing you're trying to find the max. They want us to find the maximum of the sum. They want us to find the maximum of the sum, so it helps to call this something. Usually we're lazy and we don't write out a whole word, so I'd probably just call it a letter. I could just say it's S for sum, but the sum is 2x plus y squared. And this is the thing we're trying to maximize. So with each of these questions, you're always going to have two equations. One is your constraint, one is like your requirement, and the other is the thing that you're trying to maximize or minimize. So the process, you'll always take your constraint, solve for either variable, whichever one's easier. Either it's easier to get by itself or you would rather plug it in here. Because in this case, x and y are both easy to get by themselves. Either way, you're going to have 30 minus the other variable, 30 minus x or 30 minus y. Would you rather plug something in for x or would you rather plug something in for y? X, because I don't want to have to square something. Does that seem reasonable? So I'm going to solve for x. So x is equal to 30 minus y. So you solve your constraint, you take your constraint, and you replace it here. Because the equation you want to maximize or minimize, you need it to have only one variable before you take the derivative. So the sum is equal to 2, and then in parentheses, 30 minus y plus y squared. Simplify before you take a derivative. So if we simplify, that'd be 60 minus 2y plus y squared. Again, I'm going to remind you, we're asked to find a max. A max occurs when what happens? Good. So we need the derivative to change positive to negative. So we better find the derivative. So any max or min question, you're always going to find the derivative and do like the sign chart. Derivative on these, usually it comes out to be pretty easy once you've simplified. Finding the derivative is easy. What do I do with the derivative? Good. And so to make a sign chart, how do I find the critical numbers? Good. So it's always 0 or undefined. Isn't undefined, so I ignore that. Well, this is 0. I could add 2, divide by 2, so I get y equals 1. This is our critical number, which means a possible max or min. It said non-negative numbers, so I guess I should still not draw an arrow to infinity. It's from 0 to infinity. So we have 1. We need to know if s prime is positive or negative. S prime, well, here's S prime. I'll do this one numerically. If I plug in a half, if I let y be a half, would I get a positive or a negative number? Negative. So it's negative on this interval. If I plug in like 2, I'd get a positive. So S prime changed negative to positive. That's a min. You see how that's a problem? So you can't just assume. So yeah, you're right. The sign didn't change, so this is a min. If that happens, then the max would have occurred at one of the endpoints. So this is where I didn't really focus on it, but we have to consider the domain when this happens. So the domain being just, it's like just logically thinking through this question. If two numbers have to add to 30, what's the smallest the number can be and what is the biggest the number can be? Let's talk about it in terms of y, since I wrote this in terms of y. They're both the same, so it doesn't really matter. What's the smallest one of the two numbers can be? 0, because they said non-negative. So this endpoint is clearly 0. I drew an arrow off to the right, but I really can't draw an arrow off to the right because I can't go to infinity. What's the biggest the number can be? 30. If your critical number isn't what you need it to be, in this case we were looking for a max, then that means the max occurred at one of the endpoints. If you have an endpoint and the function decreases after it, so if you have an endpoint and the function decreases, is that endpoint a max or a min? A max. Let's just check the other. Here, the function is increasing until we get to 30. Is that a max or a min? A max. Now you might be thinking, oh, dang, does it really matter? We're saying y is 0. If y is 0, what's x? 30. If y is 30, what's x? 0. So yeah, both of them would give us the max because both are really talking about the exact same situation. So if I read the question again, it said find both numbers. Well, one of the numbers is 0 and the other number is 30. It doesn't matter which one you call which. So a max when x is 0 and y is 30. Part B asked us for a min. Same question. So when did the min occur? At 1. So there's a min, but this one would be when which variable equals 1? Y. This time it does matter because if y is 1, x is something different. Yeah, Ethan.
Sorry, back to the last problem
Uh-huh.
real quick. If we take a look at both scenarios, x is 0, y is 30 versus y is 30, x is 0.
Oh, do we have to actually, we do have to check, you're right.
Because for y, if y is 30, that means our sum is 900. And that's a heck of a lot better than, or bigger than 60,
We
right?
better do our candidates test. Thank you for reminding me. So we have to do candidates test with endpoints. So our endpoints either, so the two scenarios, because you're right, we're trying to find the max of this function. So if x is 0 and y is 30, our sum would be 2 times 0 plus 30 squared, which would be 900. So the sum would be 900. Versus if we switched them and we said x is 0 and y, sorry, if x is 30 and y is 0, we'd have 2 times 30 plus 0 squared. That's 30. So the max actually occurs right here. So I said it right, but I got lucky in saying that it was x is 0 and y is 30. So we did have to compare to see which one was the bigger max.
In a test though,
Uh-huh.
you could have used any variable, right?
Yes, but as long as it would have to be consistent with how I did the rest of the question. So whatever variable you put here and here though. So since my x is times 2, that one would be 0 and y would be
And a multiple choice test,
Uh-huh.
if only had a flip flop, would it be okay because everything you could have flip flopped the variable?
Yeah, and that's why if it was on a test, they would have been specific and told you x is this and y is that. Yeah, good question. So yeah, if you have two maxes, we should always do candidates test to see which one is bigger. How? 2 times 30.
8 was 60.
60.
Still less than our
But yeah, no, I'm glad you're checking. So if y is 1, how will we find what x is?
Y is 1. X is 29.
Yeah, because we can just come back to this, how we have x defined. X is defined as 30 minus y, because they have to add up to 30. So x must be equal to 29. Because they still have to add to 30, our constraint. Okay. So this assignment, they are a little bit longer, so I'm only having you guys do 1 through 12. So your 3-4 assignment, you guys just have questions 1 through 12. Let's look at one more together. So this next one is similar. So let's look at number 1 on your homework. Okay, so you always come up with two equations. Okay, one is your constraint, one is like the requirement that you have to meet, and then your other is whatever you're trying to maximize or minimize. So it says the product of two positive numbers. When they say positive, that means neither one can be 0. So two positive numbers is 100. Find two numbers so that the sum of the numbers is as small as possible. What is our constraint?
X, Y equals.
Good. Okay, so if it says product, we know we're multiplying two numbers. The product is 100. Choose any two variables that you want. So that is our constraint. We know that the two numbers have to multiply via 100. Is this a max or a min question? A min. It said as small as possible. So they want us to minimize something. What is it that we're trying to minimize? The sum. So what equation could I write?
X plus Y.
What am I missing though? Equals the sum. So make this an equation. Right now that's just a relationship. It has to equal something. So I would say S. So make sure whatever that is, make it equal to something because you need to find the derivative. And if you don't have it like some variable, it'll be tough. Whatever you're trying to find the max or min of, we need the derivative of that to change. And so in this case, we need the derivative to change negative to positive. Phone never rings. Hello. I'm sorry. This is a teacher's classroom. I think try the main office. Okay. Okay. Good luck. I didn't know if I could just ignore it. Never. Of course, wrong number. Okay. So we know we have to take the derivative. Can I take the derivative right now? No. Never take the derivative when it has two variables. This is where you use your constraint to plug in. Choose either one, whatever's easier. You want to get x or y by itself. Doesn't matter at all on this one, right? They're both exactly the same. So I'm going to get rid of y. So I'll say y is 100 divided by x. But again, it doesn't matter. You can choose whichever one you want. This replaces y. So my sum equation is now x plus 100 divided by x. Rewrite it or simplify it to make the derivative easier. So for me, I see this as, well, I could rewrite 100 over x as 100x to the negative 1. The calculus portion of the question, taking the derivative on these, they're usually pretty easy derivatives. So now I'm ready to find s prime. Derivative of x is 1. Derivative of the next term, the negative comes down, and I minus a power. Okay. What do I do with the derivative? Set it equal to 0. Good. The two things, remember, it's always 0 or undefined. I guess I would rewrite this. This is really that. I need it 0 and undefined. What is an undefined? X equals 0. Could x have been 0 in this question? No. It said the product had to be 100, plus they said the numbers had to be positive. Two numbers can't multiply to be 100 if one of them is 0 and 0 isn't positive. So really, we only have to worry about when this equals 0. I would just add the fraction over. So I'd say 1 equals 100 over x squared. Then what? Yeah, I would just times by x squared. So x squared equals 100, and then I heard it. What does x equal? 10. How come only positive 10? Good. And it said positive numbers, right? Had to be a positive number. Okay, read the question again. It said find two numbers. Well, if one of the numbers is 10, what does the other number have to be? 10. Because the two numbers have to multiply to 100. That was our constraint. Oh, good. You're right. I skipped a step. I need to prove that it's a minimum. So I should do this where I have 10. I know it's 0. I don't really want to think about what the other endpoint is unless I have to. And on this one, I don't think I will. I just need to check each side. If I plug in a number to, here's s prime. If I plug in a number to the left of 10, let's say I plug in 5, would that be positive or negative? If I plugged in 5, I'd have 5 squared, 25. I'd have 100 over 25, which is 4. If I plug in a number bigger than 10, then the denominator is going to be bigger, so that would be a fraction. So yeah, this is a min. Okay. All right, I'll let you guys work. So the next one I think is pretty similar. I don't think any of them are too terrible. Yeah. Oh yeah, let's talk about the test really quick. Okay, the free response. I'm gonna do this actually. Okay, so here's the free response, because I think the other issue is when you guys wrote on your own paper, it you didn't have the original question, so it made it maybe a little bit difficult to go back and check. I want to turn. Rotate, rotate, where's rotate? Come on, crop that. What was that? Crop that. And then, there we go. Thank you. Okay, now open it notability. There we go. Okay, so number one, I saw a lot of students not do quotient rule, and I wish I had noticed this before, that if you just do f prime at 1 divided by g prime at 1, you get lucky and you get -3, but you didn't do it correct at all. So some of you might be like, well, I got -3, why did I get no credit? You had to do quotient rule. So part A was a quotient rule question. And it was either pretty much you did quotient rule and you got it right, or you didn't do quotient rule at all and you did it totally wrong. Okay, the most common mistake I saw on B, a lot of you didn't put this 3 right here. So this 3, this one right here, was left off. So you did the first, so the first was 3x. So you have the 3f of x. So this is the first times the derivative of the second. Well, you did that part right. And then the second, when you did the derivative of the first, some of you left off that 3. I think the answer was 5. I saw that answer a lot. So if you left that off, you got -5 or 5. The tangent line question. So you need to have 2 things in order to write a tangent line. You need slope and you need a point. The slope is just the derivative. So you had to find f prime at 3. Well, if you looked at the table, f prime at 3 was -2. So that's how we do the slope. Then you needed a point. A point is just finding f at 3 to find the y coordinate. So you went up to the table and you said, okay, well, f at 3 is 1. So that's how we got the point. And then you wrote the line. Okay, so it was meant to be a pretty easy question. Some of you guys overthought it. We did pretty good on the implicit differentiation. I feel good about how everybody knows how to find implicit derivative implicitly. I think I mentioned yesterday on your homework, the common mistakes I saw on B and C is that you found the derivative equal to 0. So you set the derivative equal to 0. You got x equals 0, but a lot of you stopped at that point. You had to take the 0, plug it into the original equation, and get to here and get your 2 points. Another thing I saw that I thought was interesting is when a lot of you were solving this equation right here, some of you did, like you added the y squared over, I think, and so you got to here, and then you divided by y. So you ended up only getting y equals -4. So you only had one answer. You want to avoid doing that because then you're missing the answer of 0. So never like divide things away. Remember in this class, it will always be factor and set the factors equal to 0. Otherwise, you'll be losing some zeros. And the last one, you can see I initially messed it up, plugged it in for the wrong thing. But so you set the derivative to undefined, which would be the denominator equal to 0. And then you get to plus or minus. Some of you just forgot the plus or minus. Okay.